Hey guys, welcome back to the channel. Today we're doing the DC analysis of a MOSFET without channel modulation. So as we see to the left, we have our circuit and some of the given parameters we have are mu n cox W over L equals 0.25 times 10 to the negative 3. Our threshold voltage is 1 volt. Important to note that this is not an absolute value sign. This sign is to specify it's positive for an NMOS and negative for a PMOS. So if this was a PMOS, it'd be negative 1 volt, but since we have an NMOS, we just use 1. We also see that lambda equals 0, so that means there's no channel modulation. And the formula that we're using here is just below. It's 1/2 mu n cox W over L multiplied by VGS minus VT squared multiplied by 1 plus lambda VDS equals ID equals IS. And really important to note, the drain current is equivalent to the source current, and there's no current in the gate. That's very specific for MOSFETs, and that's the only way we'll be able to solve them. And in this case, there is no channel modulation, so 1 plus lambda VDS is simply just 1. So what do we exactly mean by VGS? Well, VGS is equal to VG minus VS. So simply what we can do is we can find two equations, one for VG and one for VS. So for VS, we see that it's simply just going to be the voltage across the resistance. That equals to the resistance multiplied by the current. So we have 9K multiplied by IS. But since we know that ID equals IS, we can simply say VS equals 9K multiplied by ID. So now we have to find our VG. VG is going to be the voltage right here. We'll outline this in blue. That's going to be our gate current. Now, since we know that or gate voltage, since we know that there's no current in the gate, this circuit that I'm going to outline in green is essentially kind of like its own circuit. And another way we can draw this is actually just like this. With VG being at the top right corner. Now, how can we find what VG is equal to? Easy. A simple voltage divider to find the voltage across a 6 kilo ohm resistance. Or you could do 10 minus 3K multiplied by the current, but that just takes more steps. So here we have 10 multiplied by 6K over 3K plus 6K equals VG. This gives us a VG of 6.66 volts. So now that we have VG, we can easily write a current or an equation for VGS. So VG, we know is equal to 6.66. And we know that VS is equal to 9K times ID. So VG minus VS will be 6.66 minus 9K multiplied by ID. And now we can simply just plug everything into the equation. So we know the equation's ID equals to 1/2 mu n cox W over L VGS minus VT squared. And since we have no channel modulation, we don't really care about the other part. Now, what's important to note is do not forget about this ID on this side. Often people, they'll just forget about that. They won't turn it, they won't bring it to the other side and subtract 1 from the ID term. But that's really important. It could mess up the entire question. So don't forget about that. And also important to note that we will be getting a quadratic answer from this. So we'll have 2 answers. And I'll show you guys what to do once we get there. So first, let's just plug in some numbers. Oh, also, we can change ID to IS. It doesn't really matter. It's the same thing, whatever you guys want to use. So we knew that mu n cox W over L from earlier was 0.5 times 10 to the negative 3. So we multiply that by 0.5 again, we get 2.5 times 10 to the negative 4. We know VGS minus VT is going to be 6.66 minus 9K ID minus VT, which is 1. So we can simply write this as 5.66 minus 9K ID squared. So now let's solve for ID. So how do we simplify this equation? We'll square the first term. 5.66 squared is 11.32. Multiply both terms together and times it by 2. We'll get 119.88 times 10 to the 3 ID. And then we square the last term, so plus 81 times 10 to the 6 ID squared. So once we get to here, we can simply just simplify this further. We'll end up with 2.83 times 10 to the negative 3 minus 29.97 ID plus 20,250 ID squared. And now simply we bring this ID over, we subtract it, so we have 0 equals, let's make this a little bit cleaner as well, move the highest order term to the front, minus 30, plus ID, plus 2.83 times 10 to the negative 3. So now that we're here, we can simply just find the roots of each of these. I heavily suggest getting a calculator that can do that really quick because you don't want to waste time on an exam. So we simply see ID can either be equal to 1.43 times 10 to the negative 3 amps, or ID can be equal to 9.76 times 10 to the negative 5 amps. So we see we have two answers for our current. And what can we take from this? Well, simply, we know that for a MOSFET to be amplifying, it has to be in saturation mode. And the two parameters that must be met, or conditions, is VGS must be greater than VT, which is the threshold voltage, and VDS must be greater than equal to VGS minus VT. So first, let's call this current 1 and current 2. Actually, let's change the color. Make this a little easier to read for you guys. This will be current 1, current 2. So let's start with current 1. We're going to plug in the current 1 that we labeled blue, 1.43 times 10 to the negative 3, into VGS and VDS and see if these conditions are met. So remember from earlier, VGS equals 6.66 minus 9K ID. So we simply plug this in and we get 6.66 minus 9K, 1.43 times 10 to the negative 3. And unfortunately, this gives us a very negative number, negative 6.21, which is supposed to be greater than our threshold voltage 1, but that is not the case. So we know that this cannot be the current. Current 1 is not going to be the current. Now let's try current 2. So we know VGS equals 6.66 minus 9K ID. So what we can say here is 6.66 minus 9K, 9.76 times 10 to the negative 5. Now, if this condition is met, we'll instantly know that this is going to be our current. And once we multiply and subtract all these numbers, we get 5.78, which is greater than 1, our threshold voltage. So we know that this will be our current, but just to make sure, let's try current 2 in VDS is greater than equal to VGS minus VT. Now VDS, if we look back at the circuit above, which I highly suggest you guys draw out, we can see that VDS equals 10 minus 7k ID minus 9k ID. So what we can see here, if we plug 9.76 times 10 to the negative 5, actually we should have simplified that to 16k. We can see that VDS becomes 9.99 volts. And we know that VGS from what we found earlier is 5.78. So we could simply write 5.78 minus VT minus 1. So is this statement true? 9.99 is greater than 4.78? Yes. So that's how we know that the current is going to be 9.76 times 10 to the negative 5. Thank you so much for watching.